And welcome everybody to the Daily Space Weather. Starting things out with some solar imagery here. So this is ionized helium, the Solar Dynamics Observatory. And there was a C-class flare coming out of this active region, this plage up here. We captured a coronal mass ejection. We'll get to that in a moment as well. New sunspot has formed over here at Sunspot 2856. This and much more to cover on today's Daily Space Weather video. By the way, I'm your host, Dan, aka smAsho. And let's cut out the musical accompaniment and get back to some solar imagery. So let's take a look at the viewpoint from Lagrangian point 5, where stereo A is located right out here. From here, Earth would be to your right. So you can see we've got a coronal mass ejection here on the opposite side of the sun. And for you new viewers out there, our channel forecasts coronal mass ejections in this area, not so much in this area. So that's part of the reason why we didn't do anything about this. We could probably forecast coronal mass ejections for that area. We only do it on the Earth-facing side of the sun, including the poles. And we've raised a coronal mass ejection watch as a result of some phenomenon that we've been citing. Anyway, again, stereo A is located out here at Lagrange point 5, the gravitational equilibrium point that trails Earth orbitally as Earth orbits in this direction. Stereo A follows and sees space weather ahead of Earth, hence the name stereo A. Some more imagery of the closest star here, El Sol, and if you've got comments for the sun, leave them in the comments. The sun may answer them directly, I'm not sure. I don't speak for the sun. Cheers. And interestingly enough, the most X-ray output from the sun, at least on this side of the sun, has been coming out of this plage, not even out of the sunspots. Sunspot 2855 has degraded. It'll probably lose its name today. It's been degrading since yesterday. We covered it on yesterday's Daily Space Weather video. Here's a progression of the fields that formed Sunspot 2856. Great imagery here of what happens magnetically. It's the SDO magnetogram. And this one's still getting more complex. We'll give you an idea of its classification toward the end of the video. The 10.7 centimeter radial flux, the most proportional number to sunspot number, still only at 73. Here's a 1-year chart of that. The black line up here is the radial flux. Red line is the sunspot number. It's from solon.info. Here's the Space Weather Enthusiast dashboard to show no upcoming geomagnetic storms or unrest forecasted. Pretty weak solar activity continues. Let's take a look at seismicity, as we've seen a big uptick in earthquakes here over the past 2 weeks. So this area here by the South Sandwich Islands still rocking hard. Largest quake of the past 24 was a 6.3 in that area. There was also at least one 5.8 at the Philippines. And you're going to see most of the quakes here on the list are at the South Sandwich Islands region. We won't even zoom in. There's a lot of geographic settling going on down there. Crazy amount of activity there near the Antarctican / South Atlantic plate boundary. Also the South Pacific plate boundary is right in that same, it's really a tri-boundary area. Anyway, there's that 5.8 at the Philippines that came in at 1508 yesterday on Friday the 13th. There was a 5.5 north of New Zealand as well, south of the Tongan Peninsula, near the south of the Tongan Trench, in the Kermadec Trench area, an oceanic rift region. Ecuador saw a 5.0. And a small swarm of quakes there in southern Alaska as well. Volcanic activity remains high. Let's take a look. Now we've got Karimsky and Shiveluch both erupting on the Kamchatka Peninsula. So we had one, then the other, then the other, then one, now both. Volcanoes Karimsky and Shiveluch both erupting. Karimsky flight level 080, it's an 8,000-foot ash plume. Shiveluch 12,000-foot ash plume. It's an uptick in volcanism on the Kamchatka Peninsula. Karinkatan in the northern Kurils, south of there, in between Kamchatka and Kamchatka and Japan, producing a 13,000-foot ash plume as it explodes. Fukutoku Okinawa, not provided in terms of volcanic ash imagery. Not sure if it's erupting. Please don't assume it's not. Don't fly your ultralight John Denver-style aircraft over the caldera. Can't believe I have to tell people that. Nishinoshima, producing explosive activity there. 7,000-foot ash plume near the Volcano Islands, near Japan. Suminosejima, 8,000-foot ash plume from it. Samisapochnoy, an Aleutian Islands volcano, exploding, producing a 10,000-foot plume of ash. Fuego, producing a 15,000-foot ash plume as it explodes. That located in Guatemala. Sangay exploding, 20,000-foot ash plume over Ecuador from that. Revenador in that same country of Ecuador also exploding, 15,000-foot ash plume from that. Sabancaya exploding, 24,000-foot ash plume over Peru. Nevados de Chilean, intermittent emissions and explosive activity have produced a 14,000-foot ash plume of flight level 140 over central Chile. Please do not pole vault the caldera. It could be unhealthful, and we need more people to click on our links, buy our merch, support our channel, head to smashamash.com, and watch our videos. Have you seen Eugene the Philosopher on spectra, emission, absorption, blackbody radiation, and condensed matter? You can find it in our community posts, and on our playlists. Talking about spectra. Also visit our links. From smashamash.com, you can find a link to this, our Redbubble shop. And I won't make any comments about that. Other than, here's the link. It's the smAsho merch link. You can also find our social media there on the homepage. You can also find smashamash.org presents The Sun videos 1 through 9, which is also a playlist on YouTube, youtube.com/smashamash/playlists. Thanks to our patrons for being the true source of funding for the content. Patreon.com/smashamash. Thanks again to our patrons, the new ones, the old ones, and the upcoming ones. So here's the X-ray scenario over the past 3 days as measured by the GOES 16. Showing just one flare here, a significant flare in the C-class range, short-lived, and having peak flux right at 2100 hours there. 2100 hours on Friday the 13th. A C-class flare came out of that plage. A prime example of how a sunspot's not required to produce a flare and how a flare's not required to produce a coronal mass ejection. And so here's a close-up of this flare. This is 94 angstroms. And you'll see a brightening of that central region there, that active region. Some more imagery from the Solar Dynamics Observatory. No spikes in the proton flux and none expected. No coronal mass ejections headed our way at the moment. Here's the GOES magnetometer over the past 3 days. That GOES 16 is quite a workhorse. It's measuring a lot of things. Anyway, magnetometer, no real surprises there. And looking at the heliospheric current sheet, this is the top view ecliptic plane field plot, and it looks like there's a south pole current sheet headed this way. And that's not really very much of a surprise. Just keep in mind this data is 1 hour and 16 minutes old and can change with basically no warning. If there is going to be warning, it's probably going to come from our channel, but there's really no reason to be concerned about it anyway. Anyway, here's the latest image, and you can see this little South Pole current sheet could be growing. And we could find Earth in the South Pole current sheet tomorrow. If I had to guess, which I don't, I'd say it'll probably still be in the North Pole current sheet until midday tomorrow. Here's the line of sight ecliptic plane field plot, showing you a three-dimensional image of the current sheet. North Pole polarity shown in blue, South Pole shown in red. South Pole current sheet on the way. And here's the coronal hole line of sight plot, which shows you the sun's B field in blue as well. And you can see some shifts there happening in the B field as solar cycle 25 progresses very slowly. And let me just take a moment to provide a little forecast for you here. The sun is going to see a sudden rash of coronal holes. Coronal holes are extremely important in terms of understanding the solar cycles, and they tell us about the solar polar field progression process. There will be a huge uptick coming in the next 2 months for coronal holes, so expect to see this shown quite a lot more, the line of sight coronal hole plot. If you're wondering where this data comes from, it's from 51 ground-based magnetometers, which is the National Sunspot Observatory, stereo A at Lagrange point 5, and stereo B at Lagrange point 4. Likelihood of flares has gone up a little bit here as we've got another sunspot. It is growing as we make the video. We'll be keeping an eye on that throughout the day. And when I say eye on, well, the pun is intentional. Next, global geomagnetism. Pegged here at 1 over the past 18 hours. Each one of those bars representing 3 hours. And next we'll look at the real-time solar wind, which has subsided. So there was a pretty weak coronal hole wind stream here. Solar wind speed made it up to about 450 kilometers per second. Now dropping down to background levels again, pretty much. Current conditions are just under 370 kilometers per second. 369 kilometers per second for the solar wind velocity. Solar wind density only 4.05 protons per cubic centimeter. Everything else fairly uneventful on the solar wind data. Here's the space weather modeling framework of pressure for the past 4 hours. And we see pretty low pressure here with the diffuse and rather slow solar winds. And most of the pressure here showing up on the magnetotail side of the planet, not on the bow shock side. Ground magnetic perturbations, geospace delta B, changes to Earth B field. 4 hours of data on this as well. We show it since there's a polar excursion going on. This should give the most real-time-ish data about it. Again, keep in mind it's the space weather modeling framework. If you want to read about that, click on either Geospace Magnetosphere Movies page, click on Details, and you'll have a link to the space weather modeling framework. Congratulations on realizing the existence of our channel. Please press like and subscribe if you enjoy the content. And thanks everybody who views. The Smash News Network, least busted name in news. We're also on BitChute. Look for more exclusives coming there soon. And thanks to everybody who's been following us on Twitter. Almost up to 170 followers there now. And let's take a look at the solar system. So here's where things are now. We'll advance it 1 week. And there's where things will be in a week. Here's a star chart. We've drawn in the galactic plane and the shaded galaxy, as well as the ecliptic here, Jupiter and Saturn dominating the night sky. Let us know if you saw any Perseids or took any video of it. We'll feature it on the channel. Thanks to all of our contributors. We are also on Twitch, twitch.tv/smAsho, where we'll be streaming a live cosmology segment. Maybe you'll see it on YouTube, maybe not. No promises. twitch.tv/smAsho. Let's take a look at the Earth environs in terms of satellite charging hazards. We don't see any. Electron flux still at pretty low levels here. We're expecting an uptick in that. Here's the 1-year chart of the electron flux. By the way, this is measured at the F ionosphere layer, and that data is from solon.info. Here's a 3-day chart. And we can expect a precipitous uptick in this in the coming 36 hours. NOAA tends to agree. There's the electron forecast model. No surprises to our channel and our regular viewers. Thanks to our regular viewers, by the way. Here's a diagram of the Earth's Van Allen belts. The location of the International Space Station and distances in miles. We're going to show the total electron content forecast next. And this is a visualization of the total electron content, not just the F ionosphere portion, but the entire air column all the way up to a GPS satellite, which locates at like tens of thousands of miles of altitude in a geosynchronous extremely high orbit. And this gives you ideas of GPS errors, which are most common around the equator at noon. It's the total electron content forecast. And you can find different zoomed-in versions of this for your locality. If you like, we show the global view. Here's another diagram of the atmosphere showing the location of the F ionosphere layer for our next 2 frames. It's our ionosphere map, courtesy of Bureau of Meteorology of the Government of Australia. And we've recently added a frame here in the ionosphere section because we want to also include the anomalies. For people who aren't used to looking at the ionogram itself, this is in megahertz, by the way. Each one of those blobs of color represent 1 million vibrations per second difference. So red is 1 million vibrations per second, yellow is 2 million vibrations per second, and so on. Here's the latest image. Things looking anomalous around the North America. Things looking anomalous there at the moment. And we'll stop this frame at that same time so you can see which parts of the ionosphere are anomalies while we attempt to familiarize our viewers with some of the stuff going on above your head. The ionosphere in many ways is the bridge between Earth and space. And this anomaly animation is showing you the anomaly in terms of difference from the 30-day mean. Actually, we're looking at the difference from yesterday. Let me fix that. So there's the anomaly from the 30 days. And keep in mind, seasonal variations happen in the ionosphere as a result of the Earth's axial tilt, because the magnetic moment of the planet is slightly different at different seasons. It has to do with the underlying structures. The underlying structures of planet Earth that cause it to have a magnetosphere. Anyway, you can see some low-frequency anomalies here, mainly around the South Atlantic anomaly, which is now over the South American continent, right about there. Here's the latest image. That one coming in at 8:30 Universal Time. And you can see some minor low-frequency anomalies here over places like North America. By the way, there'll be a meteorology segment today as well. It'll be a separate video, not integrated into the daily space weather. You're looking at there 8,000 parts per billion of carbon monoxide. And by the way, space weather viewers, we've also made another meteorology segment today. Once again, it was streamed live at twitch.tv/smAsho. Here come our bonus features, starting with Lermonth. So here's the Lermonth, Australia ground-based solar observatory. You can see Sunspot 2856 forming over here. Some filaments down here. Again, we've got a coronal mass ejection watch in effect. If we see one on the Earth-facing side, or if it advances to warning, we'll probably make another video about it. Here's the NASA GOES 16 SUVI imagery. Again, the GOES 16, one of the ultimate workhorses. If anything went wrong with that satellite, we'd be having a bad day. And we've got a crown prominence down here, a prominence down here. Not really at the pole, so it's not really a crown prominence, but yeah, bit of a prominence there. little bit of filamentary behavior. Not sure if it's ejected or if it could be ejected to the far side of the sun. Here comes some more imagery. It's the latest intensity gram. And check it out, Sunspot 2856 is looking blurry. Take a look at it on the magnetogram. And we've got some obscurement problems going on here. It's got an interesting magnetic configuration. You can see it may have actually two different umbrae there. I wouldn't be surprised for this to be a beta class. But since we've got blurry imagery, we'll just close things out with 131 angstroms and 171 angstroms. So here's the formation of Sunspot 2856. We'll let that play through a second time before switching to 171 angstroms, my favorite wavelength. Let us know in the comments your favorite wavelength from the SDO. Those are both ionized iron ultraviolet emission spectra, if you're wondering. And thanks for tuning in, viewers. Again, congratulations realizing our channel exists, and may that solar wind be at your back.